Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. If you need global distribution, they've got that covered too, with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances, and they've got GPU instances as well. Go to dataengineeringpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you work hard to make sure that your data is clean, reliable, and reproducible throughout the ingestion pipeline, but what happens when it gets to the data warehouse? Dataform picks up where your ETL jobs leave off, turning raw data into reliable analytics. Their web-based transformation tool with built-in collaboration features lets your analysts own the full lifecycle of data in your warehouse. Featuring built-in version control integration, real-time error checking for their SQL code, data quality tests, scheduling, and a data catalog with annotation capabilities, it's everything you need to keep your data warehouse in order. Sign up for a free trial today at dataengineeringpodcast.com/dataform and email team@dataform.co with the subject Data Engineering Podcast to get a hands-on demo from one of their data experts. And you listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Corinium Global Intelligence, ODSC, and Data Council. Upcoming events include the Software Architecture Conference, the Strata Data Conference, and PyCon US. Go to dataengineeringpodcast.com/conferences to learn more about these and other events, and to take advantage of our partner discounts to save money when you register today. Your host is Tobias Macy, and today I'm interviewing Willy Lulciuc and Julien about Marquez, an open-source platform to collect, aggregate, and visualize a data ecosystem's metadata. So, Willy, can you start by introducing yourself?
Yeah, sure. So I'm Willy. I'm a software engineer at WeWork, and I've been with the company for just over a year now. Since joining WeWork, I've been working on the Marquez team in San Francisco. But previously, I worked on a real-time streaming data platform that was powering behavioral marketing software. And before that, I designed and scaled sensor data streams at Canary, which is an IoT company based in New York City.
And Julien, how about yourself?
Hi, I'm Julien. I've been at WeWork for about 2 years. I'm the principal engineer for data platform, which means that I focus more on the architecture side of the data platform. And before that, I've been at Yahoo, then Twitter, then Dremio.
And going back to you, Willy, do you remember how you first got involved in the area of data management?
Yeah, so I feel my involvement has been a bit unconventional. So what I mean by that is I owe a lot of my understanding of data management to Julien. I draw a lot of my inspiration about the topic from our earlier conversations that we had. So before Marquez was really a thing, Marquez was this really thin data abstraction layer on a diagram that Julien and I discussed, and it cut across multiple concerns. So you think about ingest, you think about storage and compute, and how interactive these components. So back then we called it the metadata layer. I know the name wasn't as cool, but this abstraction layer would eventually become and be called Marquez and become a critical core component of WeWork's data platform. So, now over a year later, since we've had that discussion, we have the opportunity to tell others about our journey, why organizations invest in those tooling around data management, and what we've learned building Marquez at WeWork.
And Julien, do you remember how you first got involved in the area of data management?
Yeah, so 12 years ago, I was working at Yahoo and building platform on top of Hadoop. So that was the very beginning of the Hadoop ecosystem and building batch processing on top of it. And so that was very interesting. We built schedulers and some new things. After that, I started contributing to open source projects like Pig, and I joined Twitter. At Twitter, I work in the data platform, also got involved with building metadata system to improve how we share data. And also I built Parquet when I was over there. And that was the beginning of having to deal with how do we scale the organization, how we manage data at scale. and building platforms on top of it. And so that's how I got to finally join WeWork to work on the architecture for the data platform and thinking about those data management problem and get it right from the beginning.
And for anybody interested, you were actually on a previous episode with Doug Cutting to talk about your work on Parquet and his work on Avro. So I'll add a link to that in the show notes as well. And so, as we've mentioned, we're talking about the Marquez engine that you've both been working on now. So I'm wondering if you can just start by describing a bit about what Marquez is and some of the problems you were trying to solve by creating it.
So Marquez is metadata management, metadata storage layer. And what it is about, it's really about capturing all the jobs, all the data sets, and for each job, what data set it reads and writes to. And this is really about understanding operations, which version of my job consume what version of a data set and produce what version of a data set. And helping with, is it taking longer and longer over time? Who do I depend on? Who is depending on me? And this problem of data freshness, data quality, all of that, having better visibility and capabilities to ensure you have good quality. And around that, that also enable a bunch of use cases around data governance, around data discovery, data catalog. And so it's really about capturing the state of your data environment. So that's kind of like the basic of what Marquez is. And it's really about the data lineage, but really from this bar graph perspective of jobs and data sets.
And what was missing in the existing solutions for metadata management that were available at the time you first began working on this project that you felt you could do a better job of addressing with Marquez rather than trying to maybe build just some supplemental resources to tie into those existing engines?
So I think if you look at tools, so at WeWork, we use Airflow, for example, which is one of the main open source scheduler around here. And Airflow focuses a lot on the job lineage and doesn't know much about data set. And if you look at other things like Atlas, they know a lot about data lineage and focus more on governance, but they don't really have this precise model of connecting jobs and data sets. So there's kind of the operation side of things, and really having a precise model of those dependencies is missing. And that's kind of why we start in Marquez, right? You also have things like the Hive Metastore, which knows about all the data sets and their partitions, and they focus a lot on the data set, not too much on how jobs depend on that data set and how people depend on each other. So there's a lot of those. I think a lot of components exist that touch around the metadata, but they don't really connect all the dots together. So it's kind of what we were trying to achieve with Marquez.
And so, in terms of the capabilities that you have built into it, I'm wondering if you can give a bit of compare and contrast to some of the other tools and services that build themselves as data catalogs or metadata layers, and maybe talk a bit about some of the ways that it's being used, such as in the Amundsen project from Lyft that we had on the show previously.
So before we can kind of compare and contrast the differences and similarities between features enabled by Marquez, we first have to ask ourselves, like, why do organizations take on this data engineering challenge to build their own in-house data catalog solution, right? So, for example, we have Uber. They have their own internal data catalog called Databook. Lyft, which I think they were on a previous episode. They have Amundsen, and then LinkedIn recently they open source Data Hub. But mainly these solutions focus on three core features. So you can think about data lineage, which is how do you track the transformation of your data set over time? What are those intermediate processes that touch that data and also derive data sets? The other core component is data discovery. So how do you democratize data? How do you get to a point where employees within your organization can trust your data and know how to, if they want to access a data set, how do they connect and pull that data? The other component is data governance. So really understanding who can access what data and do they have the right privileges to interact with that data. So, in a Venn diagram, if we take like a few steps back and look at the intersection of those features, Marquez is at the center, right? But the unique thing that we built out in Marquez is this versioning capability. So both for data sets and also for jobs. And that's really, when I talk about Marquez, that's the real differentiator and sort of the versioning logic that we built in to support, for example, for data sets, we version, and versioning ensures historical logs of changes of data sets. And for example, with Marquez, if the schema for a data set changes, we tie that to the data set version. If a column is added to a table or a column is removed, that's important, and we want to track that. Similarly, for jobs, if the business logic changes, so instead of maybe you're adding a filter to a data set or you're applying additional joining logic, we want to capture and keep a unique reference to a link in source code, a link to source code that allows us to reproduce the actual artifact of the job from the source code itself.
Visualization part of the data management. And Marquez is focusing more on the operational lineage of data and jobs. And so we actually had a quick project when we connected the two as a proof of concept of using them together. And so I think that's an interesting things we could approach in the future and see how those communities can collaborate and we can build on top of each other.
Yeah, exactly. So, before Amundsen was open source, we actually had an opportunity to speak with the Amundsen team at Lyft. So, it was this amazing in-person jam session where, we talked about metadata, and it really ended with a deep technical whiteboard discussion on how those efforts can be combined. So, if we scan the features of Amundsen, it supports associating owners to data sets, data lineage powered by Apache Atlas. It also supports data discovery, which is backed by Elasticsearch. So, for Marquez, we do have our own UI that we use to search for data sets and explore the metadata that has been collected by our APIs. But the cool thing with Amundsen, and something that Julien touched upon, was that they have an API contract, which makes pulling metadata from a backend metadata service in the Amundsen UI very easy. So that becomes a pluggable component in their architecture. And one of our goals is to provide Marquez as a pluggable backend for Amundsen.
And what are some of the other integrations that you're currently using on top of Marquez and some of the ways that you're consuming the metadata and maybe some of the downstream effects of having this available that has maybe simplified or improved your capabilities for being able to identify and utilize these data sets for your analytics?
Yeah, sure. So as Julien mentioned, at WeWork, Airflow has quickly become an important component of our data platform that's powering billing as well as space inventory. So internally, naturally, we've prioritized adding Airflow support for Marquez. So the integration allows us to capture metadata for workflows managed and scheduled by Airflow, enabling data scientists and data engineers to better debug problems as they come up. One answer that a lot of our data scientists and analysts really care about is that also common question, but really hard to answer, is why was my workflow failing? And allowing one solution to this, and the one key feature of Marquez is the data lineage graph that it's maintained on the back end. So the integration allows us to checkpoint the run state of a workflow, understand the run arguments to the pipeline itself, and conveniently a pointer to the workflow definition and version control. Some of the other integrations that we've been focusing on is with Iceberg. So it's a really exciting project that was open source by Netflix, and now I think it's incubating as an Apache project. And Iceberg is a table abstraction table abstraction for data sets that are stored across multiple partitions in a file system. So with that, Iceberg does allow us to begin to version files in S3 and capture metadata around file systems.
And as far as the capabilities that are unique to Marquez, I know that you have mentioned some of this idea of linking the jobs that produce given data sets to the data sets themselves and being able to version them together. And I'm wondering if you can talk through some of the just overall benefits that that has as far as being able to consume data sets and ensure the health of the data and ensure that you have some visibility into maybe when a schema mismatch occurs as far as a job being produced or some of the other information that you're able to obtain by using Marquez as this unifying layer across all of your different jobs and data sets.
Yeah, so there are a couple of use cases where that becomes very handy. So one is, of course, when something goes wrong, right? I think a lot of when you see data processing in companies, a lot of those framework or environment are very designed with the best case scenario in mind. Like people know what happens if the job is successful and you produce data and you trigger downstream processing. However, when something goes wrong, then it becomes hard to debug. Like, or if you need to reprocess something, it becomes hard to debug. So Marquez is capturing very precise metadata about when the job ran, what version of the code ran, what version of the dataset was read, especially if you use a storage layer like Iceberg or Delta Lake, where you have precise definition of each version of the dataset. And so when your job fails, or it's taking too long, or the job is successful but the data looks wrong, you can start looking at what changed, right? You can see if for your particular job, does a version of the code change since last time it ran? Or did the dataset shape of the input change, right? You could use things like Great Expectations, which is an open source framework for defining declarative properties of your dataset and verify that they're still valid or that it didn't change significantly. And you could look at that not only for your job, but for all the upstream jobs because you understand the dependencies. So often you have simple things happening like, why is my job not running? Well, it's not running because your input is not showing up. And your input is not showing up because the job that's producing it is not running, right? So you can walk that graph upstream until you find the source of your problem. And it may be that there's some input data that's wrong. It may be that there's a bug that got introduced. And you can figure out what's going on, right? So first, you have a lot of information debugging what's happening. And second, since you have a precise model and you know for each run what version of a dataset it ran on, if you need to restate a partition in a dataset, you can improve your triggering. You know exactly what jobs need to rerun. So I think the state of the industry is often that people have to do a lot of manual work when they need to restate something and rerun all downstream jobs. And the first capability that is required is having visibility and understanding all the dependencies, right? What to rerun. And in the future, you could even imagine using that very precise model to trigger automatically all the things that need to be rerun. Or if something is too expensive to be rerun and is not worth it, you could flag it as something that doesn't, the data is dirty and should not be used or something like that. So there are a lot of aspects like this that are important. And I think in the world where you see a lot and more machine learning jobs happening on data, having this information of that particular training job run on this version of the training set, using those hyperparameters and producing that version of the model that was then used in that experiment with an experiment ID and tying everything together has a lot of usefulness, right? Because people need to be able to reproduce the same model. So capturing this information, or if the model is drifting over time, having the proper metrics and being able to get back to that version of the training set or understand what has changed, whether in the data or in the parameters, is really important. So that's some of the, specific things we have in mind where we're looking at this very precise model of jobs and data set and what's running.
Yeah, and if I could add to that, a lot of what happens, as a data engineer, you work on a pipeline and you deploy changes periodically. But really, if you update the logic of your pipeline, usually what happens about a week or so later is really when you start seeing downstream issues with your dashboards. It's like, hey, is the data wrong? Why is I see a sudden drop in my graph or my dashboard, and that could be related to a number of things. So with Marquez, you have this highly multi-dimensional model which allows you to say, okay, which job version at what point was this introduced, this bug? And also, what were the downstream jobs that were affected by the output of this particular job version, which allows you to really, make backfilling a lot more, I think, straightforward than kind of what we see now. And really, I think a lot of data engineering teams tend to avoid that and say, oh yeah, let's just write it off as something we could address when the pipeline runs again.
Yeah, being able to identify some of the downstream consumers that are going to be impacted by a job changes, I can see as being very valuable because it might inform whether or not you actually want to push that job to production now, or maybe wait until somebody else is done using a particular version of a data set, or at least, as you said, having that visibility into what are all the potential impacts. Whereas if you're just focusing on the one job, it can be easy to ignore the fact that there are downstream consumers of the data that you're dealing with. And then in terms of the inputs to Marquez, we've been talking a lot about some of the sort of discrete jobs and batch-oriented workflows, but I'm curious too if there's any capability for being able to record metadata for things like streaming event pipelines where you have a continuous flow of data into a data lake or a given table, or that might be fed into a batch job that's maybe doing some sort of windowing functions, and how the breakdown falls as far as batch versus streaming workloads.
So we do have that in the model. So the core entities are this notion of jobs and datasets, right? And they're attached to a namespace, and that's our modeling for ownership and multi-tenancy, like jobs and dataset fall in the namespace who's producing them. And then for each jobs and dataset, we do have types attached to them. And depending on the type, we capture slightly different metadata. And so on the dataset types, we have the batch address dataset that could be Iceberg, Delta Lake, usually stored in a distributed file system like S3 or something similar. And we have the more table dataset, like if you use a warehouse like Redshift or Snowflake or Vertica. In that sense, we have a less precise model because we can't really pinpoint a particular version of a dataset. We can't go back to a specific version of the table, but we can version the changes in the schema. So we do capture that. And then the third type is a streaming dataset. So typically something like a Kafka topic, which has a schema as well if you're using the schema registry with Avro like we do. And so we can version that. And similarly, we don't have like that precise pinpointing on a version because the job is continuously running instead of having those discrete runs that a batch dataset has. So we have those three types of dataset at the moment, whether it's more like SQL table in warehouse, streaming dataset in Kafka, or batch dataset in S3. And then on the job side, similarly, you have batch jobs and streaming jobs. And a batch job has discrete runs. And for both types, we capture the version of the code and when the job started, when the job stopped. And for batch jobs, you have like discrete runs that are tied to a version of a dataset. And for streaming job, you still have runs because the streaming job starts and ends, but you have fewer of them, right? And they're more continuous. And so you have less of this, you don't have this tracking of versions of dataset, but we do track when the schema evolved. If you update your streaming job, for example, and you added a field to the output. So we do capture those different type of information. And so there's a higher level model. And then depending on the type of dataset or the type of jobs, we try to be more precise in what we capture depending on each environment.
And I'm wondering if you can dig a bit more into the specifics of the data model for Marquez. I know you mentioned the sort of different entities as far as data sets and jobs. And I'm wondering both what are some of the lowest common denominator as far as the attributes that are necessary for it to be useful within the metadata repository, and if there's any option for extending the data models for use cases outside of what you are in particular concerned with at WeWork.
So we have this notion of job and dataset, and I think maybe job is a little bit of an overloaded term, but when you define system like this, you always have some terms that are used in a specific meaning in one area and a different meaning in another area. So by job, we really define something that consumes and produces data. And so the common denominator is really this notion of inputs and outputs, and having jobs that consume and produce data. So thing that always common is you have inputs and outputs, and you have a version of the code that was deployed, and you have parameters. And for a data set, there's a physical location, an owner to it, same as for the job, right? So this notion of ownership and dependencies is common to everything. And then what we do is we do specialize in the model. We have specialized tables for each type of data set and job to capture a little bit of what when we can be more precise in one environment, because what we capture in a streaming environment versus a batch environment is not the same. So they're higher level model that's similar with input and output. And some of the other things we've been thinking about, because of course, upstream from your data processing, there are services that depend on each other as well, but the model is slightly different. So in our model, you always have this notion of something consuming data sets and producing data sets. So you always have the data set in between, dependencies between components and artifacts that people build. And in the service world, usually it's directly service to service dependencies. So it's something we haven't really spent a lot of time on, but that people start asking sometimes is how you connect both worlds, and having the dependency tracking, which often people do with open tracing, things like Jaeger, Zipkin in the service world. How do we connect the dot? Because there are a lot of, there's like a dual between the data processing and the service world, and there are a lot of those concepts that align. And so how do we connect the dot between those things?
And can you talk a bit about how Marquez itself is actually implemented and some of the overall system architecture, and maybe some of how that's evolved since you first began working on it?
Yeah, sure. So Marquez itself is a modular system. So when we first designed the original source code and also the backend data store, we wanted to make sure that the first of all the API and also the backend data model was platform agnostic. So when I think of Marquez, I always kind of talk about three system components. So first we have our meta repository, and the repository itself stores all dataset and job metadata, but it also tracks the complete history of dataset changes. So you can think of when when a system or a team updates their schema, we want to track that. So we keep a complete history of that, as well as when a job runs. It also updates the data set itself. So Marquez on the back end creates those relationships. The other component is the REST API itself. And if I can talk a little bit about the stack itself, it's written in Java. We do use Dropwizard pretty extensively on the project to expose the REST API, but also interact with the backend database itself. Um, and really the API drives the integration. So for one example that we talked about is the Airflow integration that we've done, and then finally we have the UI itself, which is used to uh, explore data sets and discover data sets, as well as explore the dependencies between jobs themselves, and allows our end users at WeWork to navigate different sources that we've collected, as well as the data sets and jobs that Marquez has cataloged.
And when I was going through the documentation, it looks like the actual underlying storage engine, at least for your implementation, is Postgres. I'm wondering what the motivation was for relying on a relational database for this, any other supported backends that you have, and what the benefits are for using a relational engine versus a document store or a graph store for this type of data.
Sure. For us, Postgres gets us pretty far. When we whiteboarded the data model for Marquez, it was a relational model, so we kind of went with that. There is going to be a point where a relational database cannot get us to the scale that we need. But when we designed the system, we wanted to make sure that it was simple to operate, and there was limited there wasn't too many dependencies that you had to pull in to get up and running. So, as we see more and more usage of Marquez internally, we will naturally kind of transition to a graph database, because that gives us more rich relationships and allow us to kind of pinpoint in a node, in a graph, the what are the relationships between a job and a data set. But that doesn't mean Marquez doesn't have uh, a graph database. We actually do. It's called Kaylee, which is open source by Google, and that's what we use to drive the data lineage graph that is a key component and really a huge feature of the API itself. A document store, I think that would be a little hard. I mean, for us, if you look at what we're trying to model, a document store would require. I mean, if you think of DynamoDB, you do have to do a lot of prefetching and filtering yourself within the application, or you push that down to the actual NoSQL database itself. So for us, naturally, it just made sense to use Postgres and then transition over to a graph database as we scaled out.
And I think one of the obvious pieces where you can help scaling that model is since we capture all the runs of a job, and when people look at what's happening, they're mainly interested in what has been happening recently, right? So you can archive all the old runs to a more key value store type model that would scale easily to storing all the historical runs of all the jobs and all the old versions of datasets. And we're still talking about metadata here, so they're kind of, it's not that much data, but it does accumulate over time. And so from that perspective, I think the relational database gets you pretty far from the number of old your datasets, right, and keeping the metadata for that. And we can add, as we see people using it on larger and larger environments and data ecosystems, you can start archiving the historical runs of the jobs to a secondary storage that scales better in volume, and for something that you may want to look at more in aggregate or something like that.
And for somebody who's interested in using Marquez, can you talk through some of the overall workflow of getting it set up and getting it integrated into a data platform, and maybe some of the work involved in actually populating it with the different metadata objects and records?
Yeah, so Marquez, it's open source, so you do have the option of just building the jar itself. So if you have a running Postgres instance and you wanted to apply the Marquez data model, you just point it to that database, and Marquez will run the migration scripts that we have that applies the schema to that database. So that's one option. The other one is at WeWork, we are heavily invested in Kubernetes. So that is one option as well. We do use a Helm chart to deploy the UI as well as the backend API itself. So those are two options that our end users do. Someone who wants to get up and running with Marquez has. We also publish a Docker image. So if your organization is an environment that runs containers and manages through Kubernetes or some other container management system, you can get up and running that way.
And then as far as getting the job information and everything, I know that there are Airflow connectors and you have native clients for Python, as well as a Dagster integration that I noticed is a fairly recent addition. So I'm wondering if you can just talk through some of the other work as far as once you've got it up and running, just the overall work of actually integrating it into the rest of a data platform to record metadata and job and dataset information. And then also on the downstream, setting up consumers for being able to take advantage of that information.
Right. So as you mentioned, we do have a Python client. We do also have a Java client, and we're working on a Go client as well, because there's a lot of applications that are written in Golang at WeWork. So really, the integration itself requires this Java client, these clients that really implement the REST API. So a lot of when we do integrations with our internal platform components or integration with open source project like Airflow, what we end up doing is using the REST API. So we have an API for registering source metadata, metadata around data sets, but also an API around jobs. So really, it comes down to just understanding when your pipeline is running or when your application is running. What are the friction points? So really, what we care about is when does your application access data, and also when does it write data itself. So those are the two key integration points that we care about.
Yeah, and as those integration are contributed to the project, really there's less and less work to do for people to integrate. So today, if you use Airflow, you have the Airflow support right away available. But some other companies use a scheduler called Luigi. So currently we don't have Luigi support. So someone who wants to use Luigi with Marquez would have to write a Luigi integration to send the same information. But once that is done, everybody using the Luigi scheduler would benefit from it. And so the same applies to Spark. So we have integration for the Snowflake, Redshift, SQL, and that's something that everybody can leverage. And really, it's something that that's one of the reasons for open sourcing Marquez is really it's something that becomes more valuable the more it's used in the open source, right? Because people contribute those integrations, and then the more we have, the more it's easy for anyone to use it right away without much work. And so that's kind of the advantage of open source in this kind of project.
Yeah, and in terms of kind of like continuing on that, so the one exciting integration that we've done with Airflow is we do provide a SQL parser. So a lot of the time, what we see is Airflow is used for ETL workloads, mainly sort of reading from S3 and then writing to your warehouse. So what we ended up doing was we have this built-in SQL parser that really understands what are the tables that are part of your SQL statement, what are the tables that are part of your join, and also what tables are you writing to. And the key thing when we were looking at integrating with Airflow, we want it to be really easy, just drop and play. And if you just have to do a one-line change to modify your library in terms of what import you're using, we wanted to make that really, really simple. So it's just a one-line change, and by default, you get all of this rich metadata sent to Marquez, and by default, you get a lineage graph that sort of cuts across multiple Airflow instances. If you're doing, depending on your deployment, you could do a multi-tenancy deployment in Airflow, or you could have single instances. So there is that opportunity to, stitch together the interdependencies between workflows.
And in terms of the actual separation there, do you have a different deployment of Marquez for production versus pre-production workflows, or do you have it all in one UI so you can view the entirety of your datasets across all of your environments?
Yeah, so we follow a fairly standard deployment process. So we do have a staging environment for Marquez, and most of that really is our sort of dummy data, but also if someone's testing out a new pipeline, we do have that reported to the Marquez backend. And then we also have a deployment process for production. We sometimes do sync metadata from production just to kind of see, to provide a more populated metadata in staging, so that way we can start querying. Okay, we added this new field. Does it really make sense? Should we drop it? Does it really answer the question that we've been trying to ask? But yeah, we hooked into CI, and we have a continuous deployment to both staging and then also production.
And as far as the assumptions that you made and the ideas that you had going into this project, what are some of the ways that those have been challenged or updated as you've actually started using it in production and exposed it to other organizations that have started employing it for their environments?
One of the metrics for the success of Marquez is looking at coverage of Lineage. So when we look at that, sometimes it's a little bit of a moving target, right? Because in the Airflow integration, so we integrate with Airflow, and we have multiple instances of Airflow for multiple teams. So right away, as you deploy the Airflow integration, you see all the jobs, but you may not see all the lineage right away, because to capture the lineage, then we have extractors that figure out the lineage for each type of operator people are using inside of Airflow. And so when we define targets in terms of we need to cover all the operators that people are using, and we start working on that. Meanwhile, of course, people keep innovating and using more operators. And so making sure you define a more standardized way of working together, and making sure as we include more operators, we don't have more and more that needs to be integrated is a challenge that we've seen in the past. And so it's kind of important to work with your users. It's kind of having how do you make sure that your coverage of lineage target doesn't become a moving target, right? And you keep the more lineage, the more coverage you add, the more coverage you need to have. And at the beginning, it was a bit challenging, but as soon as you start paying attention to it, it actually works pretty well. We've seen some effort, like people were starting using DBT to have lineage information in their jobs, but then they have like lineage information for inside the team, right? And Marquez gives you lineage information across the entire organization. And so just working together has been important, and making sure we have like aligned goals on how we build that. So that's been a little bit challenging from that aspect.
Yeah, and it's funny. We do version our DB the schema that we do have for Marquez. So I think we're on version maybe like 21. But if you look back at what we initially had, it was just I think three entities where you had job, datasets, and runs. And if you fast forward to where we are now, we have a far richer data model where we capture not only the run args, but also we capture the context around the job itself. So recently, with our Airflow integration, we wanted to capture the SQL. So, and that way we could display it on the Marquez front end. So we added this job context field, which is just a key value pair that allows you to store additional information about the job itself. When we first started, I think the most like tricky part for me was to really understand how we were going to provide this extensive metadata model that allows us to version data sets. It was always theoretical, but once we kind of got it running in production and our first integration with Airflow allowed us to really expand and implement that versioning logic, which, kind of looking back now, it was a far more bigger task than I thought it would be. And right now, it's just fairly simple versioning functions depending on the data set itself. And also, we did kind of expand on ownership of metadata. So with a namespace, so a namespace allows you to group metadata by context. So initially, we tracked it at the job level, but then we kind of moved that up one level where we now tie ownerships to data sets and jobs. So really, there was just so many additions and modifications that we've made uh, in the past year from our first whiteboard session and the first data model that we had for Marquez.
Yeah, I think it's really important to have those entities and their relationship right, because from that, then it's really easy to add more metadata around each entity. But the evolving the relation, the entities themselves and the relation between them is a bit harder, especially once you're in production. And so having this notion of job version, runs, dataset version, and inputs and outputs, and really having the right modeling of what the world looks like enables a lot of this.
Yeah, and one last thing, when we thought about the meta repository, we didn't really want to store schemas. We didn't want to become a schema registry that stored all the data set fields. But what we ended up seeing was the need for that. So Marquez now is able to version fields of a data set and tie those to a version. So we care when we capture metadata for a data set, we also capture its fields. So we have the name, the type, and also the description itself, which is, I think, a direction that I didn't think we would take. But man, it's really kind of paying off, and we're seeing some really cool usage based off that.
And in terms of the description, I know that one of the most valuable aspects of having a metadata repository and a data catalog is being able to capture the context of the data sets so that you can understand what their intended purpose is and some of the information that went into the decisions as to how it was produced and some of the schema that was formed. And I'm curious what level of additional annotation is possible beyond just a free-form description field, or some of the interesting ways that you've seen that leveraged?
So we have some tagging features, and it can be used to leverage, to implement privacy or security aspect, or encoding SLAs. Right? Is my data experimental? Is my data production ready? Those kind of aspect that people can use it for. Other aspect is adding data quality metrics in the dataset. So we've been experimenting with Great Expectations to do this, and then people can decide. Usually, it's used in two ways. Whether when you're producing the data, just having some declarative properties enforced on your dataset and fail. You don't want to let anybody see that dataset if the code may run and not declare any errors, but the result is not correct. And so that can be used as a circuit breaker to not start the downstream jobs and never not publish this dataset. Other ways people use it is actually the consumers may have different opinions of what the data quality should be for them to run their job. So they can also use as a pre-validation check, like enforcing certain data quality metrics before consuming a job, and preventing bad data to percolate through the system, right? Because then it can be expensive or have impact in production, especially if you're doing machine learning or recommendation engine or things like that. If you have bad data going in, then you have bad recommendation coming out, right? And that has a real impact on production systems. So those are some of the ways people are using it. So there are always two aspects. Either you have a more generic tagging or a flexible type of metadata adding to an existing entity, or if it's something that can benefit that's from being included in the core model, then it can become like an actual attribute or an entity in the model.
Yeah, and the one way we plan on using descriptions is for our search results. So if someone's searching for a data set and they happen to provide a description for a data set, we want to reward the owners of those data sets by moving those data sets up the search results. Because we do make descriptions optional, but like I said, we do want to reward our end users for putting the extra effort to annotate their data sets.
And we've talked a couple of times about the health of a data set, and you mentioned, Julien, the idea of using something like Great Expectations for being able to populate some of these data quality metrics. And I'm wondering, what are some of the other useful signals as to the overall health of a data set? And then also things like the last updated field for indicating when something might be stale, or when you might want to get some additional information about why it's not up to date or why it's in a particular state as far as the health or the quality.
So data freshness is often a property of data that you see. So yes, things like, to me, data freshness is really more an attribute of the pipeline producing the data, right? Like, people look at data freshness when all they see is their data set, and they say like, oh, when was the last time my data set was updated? But really, other thing you can look into is it taking longer and longer to produce this data set, right? And does it retry? Does the system fail and retry a couple of times before working? And those are all attributes of the jobs producing the data. And so that's kind of part of the importance of understanding that graph, right? And a lot of those data transformation, they're not linear, right? Most people, they start with the data set size, and as they're being successful, their input size will grow and grow. And the job that consumes that data, it does something with it, may take longer and longer, right? A join is not a linear time operation. The bigger your data set, the time it takes is not proportional to the input. And so those are kind of things that you will have to maintain your pipeline as you go. Something that was working early on in the life of your product may not work later, just because the processing time doesn't scale linearly with the size of your input. And so that's one basic one, like data freshness and understanding why it takes time to do something. Also, as you get more users or more data source, like the shape of the data may change, right? The distribution of values, and that's also can impact processing or data quality. So Great Expectation is one way to get more information about the size of your input. Another one is looking at how long does it take to process the data. If you have failures, it's important to correlate with how is the code changing, because you may have changed an algorithm and added some functionality but break something else. And so how all those changes, as your organization grows and more people are involved in modifying the pipelines, the more you have different conflicting changes that may have impact on the overall system. So several of those are interesting attributes of the data, in the data freshness, data quality, and sometimes it's important to just look at the business metrics also that derive from it, not just like the data property itself, but what are the metrics of, like, if you do a recommendation engine based on that data, just having Great Expectation metrics on how is the distribution of a column evolving may not be sufficient, right? You may want to track metrics downstream from that, is how does that affect the user engagement in some way, and connect that all the way to how the input data set change.
And what are some of the interesting or unexpected or challenging aspects of building and maintaining the Marquez project that you have learned in the process of going through it?
Yeah, there's been some growth, so Willy mentioned before how we evolved the model to how do we get to this precise and good model of those entities and starting the integrations. I think once you have this good model, then you can start having more integrations in parallel, right? Because once a model is more stable, it's easier to build more integrations, and whether it's schedulers or processing frameworks like Spark and Flink and Kafka and all those things. So that's one challenge. The other challenge is about one thing we did early on is make sure we talk to other companies to validate the use cases and validate the model. And so in starting building that community. And the second aspect is talking to other companies is whether they want to use the open source project. And then the next level is, do they want to contribute to the project? And so making sure that we are all on an equal footing, building that community, right? So it's kind of like, so we started with having this design doc in the open and validating the use cases, validating the model, working with other people at other companies, and working with others, trying it out, how we work together, and making sure we do all the development in the open so that everyone feels we're all on an equal footing, building that project. So I think it's part of the challenging, right? How do we make sure this project, which is going to become more valuable the more people use it, we all we all have a feeling of ownership of it, and it's really a community-driven project.
And so Marquez definitely looks like it provides a lot of value and utility for being able to manage the health and visibility of different data sets across an organization. But what are the cases where it's the wrong choice and you'd be better served with a different solution?
So one thing we keep mentioning in this model, right, is there's this strong notion of jobs and data sets, right? So it's kind of Marquez relied on this notion that you have things that depend on each other through data sets. So this like asynchronous type of communication where you produce a data set, whether it's streaming or batch data set, and someone else will consume that data set, right? So that's how we model dependencies. So that works well for any kind of batch and stream processing type of jobs, right? It's called, this whole data ecosystem kind of works like that, and that's a model. And so we capture this information. If you're in an environment where you have, every request looks different, and like depending on the request, you may be sending an event to a lot of different things, and or you talk to different type of services, then that's not necessarily the best model for it. Like if you look at things like open tracing, or the projects like Jaeger, Zipkin, other projects that are similar, that look at how do requests flow through a system. They may not look the same depending on the request, right? And you may have a lot of dependencies between the microservices. Then Marquez is not necessarily the best model. So we'll definitely look in the future how we connect those two worlds, because there's a lot of interest in understanding the lineage of the data, not just when it enters Kafka or whatever data collection system you have, but also understand upstream where the data is coming from. But it's still a different model, right? So I think in that case, Marquez is not necessarily the best system to understand how your microservices depend on each other. It is kind of a related world, but our model is really about this more asynchronous communication between systems through data sets.
Yeah, so what I found most challenging is, I think, controlling the story around Marquez, because every time, internally at we went to different teams. They had different assumption on what Marquez was, and also the type of metadata Marquez was storing. So depending on who you talk to, it would be metadata around services, or it was metadata that was very general, and you could store whatever you wanted in the repository. But the key thing that I always had to kind of drive was, Marquez is relevant and also most useful within the context of data processing. So that was probably the most difficult part, is sort of educating our end users on why this is important, what it unlocks, and what they could actually do with the metadata that's stored in Marquez.
And looking to the future of the project, what are some of the plans that you have, both from a technical and organizational and community aspect, as you continue to evolve and grow it?
So from a technical standpoint, like now that the internal model is stable, having more integration, like I mentioned, Luigi as another scheduler, other things people are using for processing data and understanding the lineage. So, and that's a part of the project that can really scale in parallel, right? Different people, users can contribute different integration in parallel, and that scales very well in an open source project. And for example, why doing Parquet, once a core model and format representation existed, having integration with a lot of different things, whether it's Avro, Thrift, Protobuf, Spark, Hive, all of those things, it was really easy to work those in parallel. So I think we're at this step with Marquez, and that's really the next step, is how we build all those integrations so that it becomes more valuable. Another next step, which to me is a natural next step for a project, is to move to possibly a foundation, right? So kind of the next, if you want to really show that this project is not, it's community driven, not owned by any particular entity and not controlled by any particular entity, and everybody is on an equal footing on helping evolve the mission of the project and making it successful. That's really kind of a good testament in showing that, look, it's owned by open source foundation, and that's how you can help driving community involvement and more contributors, because they know that they're going to be on an equal footing to everybody in the community. So that's also, to me, a next step we're thinking about.
Yeah, and for me, I think the next step, building on top of the metadata that we've collected so far, because that unlocks a really cool feature that we've been discussing, is data triggers. Since Marquez is aware of when a job modifies a data set, imagine if Marquez also wrote that change log to a queue somewhere, which then a backend system would listen on and trigger a job based off the data set being modified. The other thing that you can think about is, having some sort of health quality check, before the job is triggered, enabling you to be like, before I actually kick off this job, are all of the partitions that are required for this job to run actually present? So we could do those type of health checks at that point. So for me, it's just there's so many more things that we can do with just the metadata that we've collected so far, and yeah, so I'm very excited about the future of the project.
Well, for anybody who wants to follow along with the work that you're doing and get in touch, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today. And I'll start with you, Willy.
Yeah, for me, it would have to be the tooling around sort of ensuring the quality of the data set that's part of the input of your job and also the output of your job. I think we've seen over the years amazing tooling around code and visibility in code. So you'll have logging for your application to understand the runtime. You'll have metrics for your system to understand its performance and also the load on your system. So there's very little of that we see in the open source around data sets themselves. And I think that's where Marquez really fits in and the problem it's trying to solve. And as Julien mentioned, Great Expectations is one of those really exciting open source projects that allows you to define the shape of your data as well as the expectations that you'd like to see before you actually process that data set.
And Julien, how about yourself?
So related to what Willy just said, I think like the data operations in general is kind of a big missing point, because you see from the service, in the service world, there's a very mature way of how do you write unit tests, how do you deploy, how do you monitor your application, how is your on-call rotation working? And in the data world, I think they're not that much either tooling or even best practices that are defined, right? So part of building Marquez is really about how do you take ownership of your jobs? How do you understand what you're depending on and who owns the data set you're depending on and the job that produces it? Who depends on the data set you're responsible for? And how, as companies grow and you have more and more teams that depend on each other through sharing data sets, and how we build this really good culture of data ownership and depending on each other and how we are on call for it. And especially in a world where machine learning is becoming more prominent, problems in data affect more and more production. It used to be that when a service is down, you most likely impact something right now. When a batch processing doesn't work, well, maybe you'll impact something in a few hours or next day, and maybe it's less urgent. But it's becoming more and more urgent and important to have a good, production practices around data processing. So I think that's one of the gap, and that's where Marquez kind of help. And also it connects with all those other aspects of governance, discovery, but also how are you ownership of data set and jobs and how they're produced.
Well, thank you both very much for taking the time today to join me and discuss your work on Marquez. It's a pretty interesting project and one that I look forward to taking advantage of for my environment. So thank you for your efforts on that front, and I hope you enjoy the rest of your day.
Thank you, Tobias. You too.
Yeah, thanks. I always enjoy talking about metadata, so this was a great discussion.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.